Hello everyone, it's Peter here, Piotr Fisner. How are you doing, guys? So, in today's episode, why my second color is... Anyways, we've got a backlight here, okay? Those who know this backlight, this is from customer's old TV. It's nasty. See, here is clean, but on this side is all burned. So it was replaced, TV is working, yes, another TV is on the table, this time is a Sony. Let's try to remove those single diodes if we are able, if they are soldered or they are just either welded, you know, like a spot welder or something, you know. Just let's try. Let's get this one, and let's get, we don't need a lot of air, but we need a lot of temp, yes. So I will set a maximum temp 480 degrees, okay, and let's try to heat up on the very end. At the very end, start to smell with a plastic burn. See, so it's not soldered. Oh, stinky. Really stinky, and it's still not going off. So we don't want to do like that because we will burn the diode. For those who don't know, 480. Nope. If there is a technique to remove these diodes, let's do more max air. Oh, but it's broken. It's not removed by solder, it's just... Oh, maybe. It's stinky. It's really stinky. Okay. Wow. Let's get the airflow to the half. That should give more temperature in the shorter period of time. Doesn't want to go. Because if I would get these diodes somewhere, I would be able to use... ouch! Don't touch it. Super hot. Super stupid to touch it. What about you? Oh, this one went on its own. That one has stuck to the surface. That's surface mounted. Definitely. Okay, so some of them are going better, some of them are going worse. It's not worth the energy. It's 750 watts, this Yihua 882D. Yes, it's cheap, 40 to 50 pounds. hotter. But the energy, the electricity is not worth. Nope. Okay, so those which are burned diodes, they acting differently than the good ones. Okay, it's not, guys, it's not worth. I would say, okay, I would say that this process, it's not worth a hassle. Now the last thing what I wanted to show you, or what it does, okay, is those diodes underneath the microscope. So let me cool this one off, let me switch to the microscope and I'll continue the video. Okay guys, so it's looking like it could be soldered actually. That's what's looking like. Yes, that's the back of it. And that's the front. So you see, even though we removed it, we didn't damage the diode, yes? So yeah, probably still, if it's a good one, still okay. Now let's check the condition of this strip here. I'll take out the light. You see that, so that's what it is. Okay, and they are in series. So if we could use the soldering paste and the heat from the bottom and align diodes, we would be able, in theory, to solder them back. The only question I've got to myself is why some of them don't want to let go so easily. So yeah, no, we can get rid of them one way or another, but the whole point was to, you know, have like a heat plate or something which will have consistent heat, and then you could do one after another maybe, because hot air, it's 750 watts and it's, you know, it's not that worth. But I would say that this is really not worth. Let's switch to the camera. I'll explain how I see it, okay? So, in my opinion, if you're going to do this process, it could be okay for years, or it could serve for weeks, months, and you don't know it. Whereas if you buy a new strip and it doesn't miss, like here, one teeth, yes, one diode, it's just full, yes, you know this will last for X amount of years. Now, we probably could even extend the life of those diodes if we would mount additional strips at the top of the tally and split them into sections, then supply the voltage for each of the sections, because I don't know how many sections it is. We would have to open it here and then see, check how many volts and amps each section receives, and then calculate if it's safe for the diode to receive that much, if we would know which diode has been used. So if we would have rows at the top and rows at the bottom, automatically you need less power for these diodes to use for the polarizer to spread the light across. So that's one way to go, yes, and then you would save up on the lifespan of these. And for sure it's possible, because Sony, yes, Sony backlights tend to last longer. Not always, but quite often tends to last longer, whereas usually 3 to 5 years and we see backlight to wear off. So the question is, can we make our TVs last 10 years and more? I would say with additional row of backlight added from the top, not only from the bottom, lowering the brightness of the LEDs and spreading volts and amperes across each smaller section so that they won't push through so much current, I would say it's achievable, yes, plus control the temperature and maybe put thermal sensor, and when you see that the thermal sensor is on, you don't need even microcontroller for this, because you've got those thermal sensors which will send impulse, and you can have a diode, and the diode can be, let's say, underneath the TV, and when you see that diode light up, you know that the temperature has raised, and then it's of your concern to do something about it. So I would say if less LEDs now works and they light up brighter, they should in theory create more heat, yes, and then those strips could need replacement. But what I want to say is, in regards to these are really like cheap, yes, so I wouldn't say there is a value for us if we don't have spare electricity and time, and then we need to buy these diodes, and then we need to use soldering paste rather than using solder, yes, to mount them. So it is quite a bit of a hassle to go through it, so it's better to just buy a full strip. That's how I see it, yes. Don't get me wrong, you can still fix it this way, and especially if you're skinny on money or something, you can still do it this way, but it's a lot of hassle, yes. It's a lot of hassle, it's not nice. I thought we won't remove it from this, yes, I thought we won't, and I'm positively surprised that we were able to remove it. Now the question is how many sections is here, but we won't test it now, it would take us too long. As we see, there are several, because it's 1, 2, 3, 4, 5, 6 connectors. If we will take that, one is a ground, it's a common ground. I don't think there will be more. You could test it with digital multimeter here, and then the rest would be sections for those. So yeah, if this would be 5, it's 1, or like those bigger ones, 1, 2, 3, 4, 5. So that would be one section about, yes, that would be one section, not another section, and that's another. Who knows? So maybe, just maybe, if we could have as well something like the sensor in between them in series, then if that would give you notification that one of the sectors is dead, then you wouldn't burn the polarizer, which would then expand the life expectancy, lifespan of the TV, because if your polarizer is good, which is spreading the light across the screen, then the biggest cost you might have, screen or the polarizer, you know, it's saved. So then you only swap LEDs, and if these would be mounted like in Sony, that you don't need to open the whole TV, but you can just literally open the back cover and all the electronics here, yes, then that would be extra benefit. So I think our TVs, if we will ever build them, will be made in such way, yes, as I described here. Hopefully you see how these are built, hopefully you get a lesson out of it. I wanted to do it so that you can learn on our work as well. And thank you guys for watching. That's not a secret about this backlight anymore, so thank you for watching, see you in the next one, and if possible leave a like button here under the video. Thank you, bye bye.